6-4. Confidence intervals. Okay, we're on our fourth section. So far, every single section starts with the same. Confidence intervals for the population. We had mean large sample, mean small sample, and proportions. Today, for population variance and standard deviation. The symbols for population variance, do you remember?
No.
What's the symbol for population standard deviation? This one you should know. Yep. It's O squared. So those are the two symbols that we are finding the confidence intervals for. Okay. Just some facts first. For normally distributed data, so say we were doing heights of people or IQ scores or weights of objects, that data is going to be normally distributed. So for normally distributed data, first thing, if you're to keep doing a bunch of sets of data and now look at the variance of each set or the standard deviation of each set, if you were to make a graph of just variance and standard deviation, that's not normally distributed, but it's okay. So the first thing is that the variance and standard deviation distributions will be skewed right. But the original data, whatever you're gathering, is normally distributed. But when we start to look at just the variance and standard deviation, we graph that, you'll get a skewed right graph, but that's okay. And then the second thing, because they are skewed right, we have a new graph, new table. So, because the data is skewed right, the critical values are chi-square values. And the Greek letter chi looks like a big old X. Chi. And chi-square, just put the little square by it. Take out that t-table I gave you and flip it over. You will see a chi-square distribution table. So we're on the back of the t-table.
Wait, so it has little...
Yeah, that's the Greek way to make it.
Too much work. Too much work, not enough. You don't need this anymore?
Nope. So the chi-square, if we look at this, first I want to compare back to the z-table. Remember, the z-table is always based on the area to the left. Okay? Now this one's to the right. Wouldn't it have been nice if they were consistent?
No.
Yeah, would have been nice, but it's not. So, the chi-square, the chi-square distribution does start at 0, and it is a skewed right graph. Remember, skewed right means it tails to the right. we will be putting our confidence level in the middle here. Remember, the normals are 90, 95, and 99. We will have to, and because these are not symmetrical graphs, where the z-score is symmetrical based off of that 0, we have the positive and negative, these are going to be two separate values. You have to look both of them up. So we call them chi-square left and chi-square right. And both of them are based on how much area there is to the right. So it's area to the right that we need to know. So we're going to practice reading the table before we actually get into this. And notice the left-hand column again is DF. What did DF stand for? Degrees of freedom. And how do we get degrees of freedom when we use the t-table? N minus 1. Same thing here. So it's area to the right and degrees of freedom that we have to look up. So area to the right and DF, degrees of freedom equals sample size minus 1. Those are the two things you need to know to find your critical chi-square values. So let's practice reading the table before we do our three-step process. Okay, can I get rid of this?
Yeah.
All right. For example 1, reading the chi-square table. So let's say we had a 95% confidence interval and a sample size of 25 for normally distributed data. Can you find the chi-square left and chi-square right? So, if you make yourself a little sketch, the chi-square graphs are always skewed right. Not that you have to make it that way. The main chunk is our 95%. How much area does that leave for the two tail pieces?
0.025.
0.025. And this piece back here would be 0.025 if we needed it, but we don't. So, if we want to find this chi-square value right here, the chi-squared right, this one would be because it's on the right, you need the area to its right. How much area is to the right of this thing? 0.025. So we're going to look up 0.025, and degrees of freedom would be 24. So grab your chi-square table. If you look, we want 0.025, and I see that right here, the chi-squared for 0.025, and 24, 39.364. Everybody good at reading that table? Take the time to find that. Make sure you can read it. Okay, I need to find this chi-squared left value. Well, in order for me to find it, I need the total area to its right. How much total area is there to the right? 0.975. You're going to look up 0.975 and 24 degrees of freedom. I don't know what it is. Or what'd you get? I guess I do know what it is. 12.401. So total area to the right and degrees of freedom. because it's in the formulas. All
Oh,
right.
I see. See, I have to subtract.
Are you good?
Yeah.
Okay. So that's just reading the table. Now, how do we find a confidence interval for variance and standard deviation? It's just a plug and tug formula. So, confidence,
How long is this?
not long. Interval.
More than 4 lines.
I can do it in 4 lines.
I can stretch 4 lines.
It's really not a 3-step process. It's just a plug and tug formula. So the variance one, the interval is going to be found, the smaller part of the interval is n minus 1 times your sample standard deviation squared divided by your chi-squared right value from the table. The upper end of the interval, the numerator is exactly the same, n minus 1 times s squared, and now you divide by the chi-squared left value. That will give you your confidence interval for variance.
Simple plug and chug.
Simple plug and chug.
No.
Standard deviation interval? You tell me, how would you get from sigma squared to sigma?
Doesn't work. Square it.
You're just going to square root both of those answers.
Explain how that all works.
So you square root your answers from above.
No, I thought it was.
Sure.
Yes.
Oh, never mind. Just figured it out.
Okay, I've got 2 examples.
Wait.
How long are these?
About as long as the ones we've been doing. It takes longer to write all the stuff down than it does to actually make the interval.
Do you like calculators or just
I don't know. Are we ready? There we go. Number 2.
Don't worry, I know what you're trying to do.
Yeah, right.
like for another thing?
I know what you're
James, Josh. What did you say?
Okay, someone isn't always listening. Why?
I think it's, no. Might be fair, but I was just making up.
How are you in the middle from the
Why don't we just there's friendly pictures of ice cream? That's common.
We are very
What?
active.
Sorry, where did you get?
The Messiah is coming. Well, you better become Josh. I just think
Okay, we're looking at allergy meds. And we're looking at how much variance, guys listen, we're looking at how much variance there is in the weight of the allergy med. Is that an important statistic for the people producing these allergy meds?
Yeah.
Absolutely. They can't have a lot of variance in the weight because it's all dependent on, a person's body weight and stuff, and they give them the right amount. You can't have a lot of, so they want this variance interval to be very, very small. Otherwise, we've got to reset the machine that creating these. So those are the kinds quality control people would care about variance intervals, because you don't want a lot of variance in each pill. So that's who's going to do this stuff. So let's see how much, what the variance of the weights would be for all of these allergy meds based on this sample. So again, how are we going to know on the test Friday which section to go to? Well, you read what confidence interval you're trying to find. Construct the 90% confidence interval for the variance. Doesn't say means, doesn't say proportions, says variance. That tells you to come here. So now you know you're just going to follow that little plug and chug formula. But we need to find the hard part is finding the chi-squared values. Then you plug in. So if we make the little sketch for the chi-square values for variance, we've got 90% confidence. So you've got to figure out what's in this right-hand tail piece. How much area is in the right-hand tail piece?
0.05.
0.05. Okay, how many degrees of freedom are we going to have for this problem? Oh, I forgot to tell you, 30, missed it. Select 30 allergy meds. Jumped right over the number. 30 allergy meds. So that makes our degrees of freedom what value? 29. Go ahead, you look up the two values, I'll compare, we'll see who's reading their table correctly and who is not. Hey, any problems finding those two values? Everybody's good? James, you good at finding those two values?
I'm sorry, I was just thinking about something.
Yeah. Think about this. Okay, so now we're ready for the variance interval. So it's n minus 1 multiplied by the s value. Where's s in this problem? This is the s. It's the standard deviation of my sample of 30. We want the chi-squared right value here.
1.2 or 1 times 2?
1.2. And then the other side of the interval, numerator stays the same. Denominators are other chi-squared value. It was it? Oh, it's s squared. Forgot the squared. Squared. I forgot the squared on the 1.2.
They all mean. It's the bridge thing, what they do.
Oh, yeah,
Push
which
the guy into the river.
Yeah, he runs away and stuff, man. Almost made it.
I think the book still goes 3 places on these. So what's the low end?
That's it right
I got 0.9.
That is correct. Remember, you want a very small amount of variance here, so they should be small numbers.
Yeah, I think I screwed up.
Yeah, those are squared. I missed them when I went through. Yep.
That's right.
Yep.
So I think
Yeah. We're still scared of that answer. Why is it 2.35?
And remember, these are milligrams squared.
Oh.
So, I mean, it seems big, but it's actually milligrams squared, which doesn't mean much to us. So in terms of milligram, we would be square rooting that, which would bring us down to 1 point something milligram, which still seems a little bit high to me, but. Okay, last one, and you'll see why I did it here in a minute. Okay, number 3. Okay, so we're going to select 23 MP3 players, so we're going to say prices are normally distributed. Okay, select 26 MP3 players. The variance of the prices is 2.25. Find the 95% confidence interval for the standard deviation of the prices of all players. Prices are normally distributed.
I thought that said Prius at the end.
So, 95% confidence interval for the standard deviation.
Prius are normally distributed.
No, prices. Okay.
Oh, I wrote
Prices, because I went into that. There we go. Okay, so first thing because we're working with standard deviation distributions, we need our chi-squared. So find the chi-squareds first. Then we'll go into our plug and chug.
I'm always going to call this chunky, just so we're clear.
So 95%, 2.5%.
Oh. Isn't she a few?
Look these up.
Don't we already have them?
No, they change with sample size.
Oh.
So it's not like z-scores, because the degrees of freedom is going to change.
Hey, don't bring him into this.
39.364.
I do not have that as an answer.
For
40 point, how about 646?
Yeah.
Oh, I was looking at 24.
Yep.
Way to go.
Yeah, there's that.
I subtracted 2 with 1.
Is it 646 or did I write it wrong?
I got 646.
646. Okay. And then the small one? Okay. Now, be careful. Here's the catch. What is this 225 that I gave you?
The variance.
It's the variance.
Square root of that. That's right.
So that is S squared.
Why would you go into that?
Because they can. This is S squared. So when we plug it in the formula, we're not going to square it again.
I'm gonna get that wrong.
Ah, that's why I did this one.
So we're just going to put it in the formula without the square?
Correct. So here we go. So we're doing the standard deviation interval, which requires our big square root, and then the formula. It's 26
Oh, right.
minus 1,
Just
2.25 without the square this time, over the 40.646.
No, you don't square it because it's variance. 2.25 is the variance.
See, they had a conversation going on during that important thing, so they don't know why we didn't do that.
Everyone's screaming over here.
Oh, you're gonna call them screamers when you were right in that conversation? Shame on you.
Oh.
Shame on you.
Why is the...
Blame everyone else around there when you were like probably the leader of the pack.
Yep, it was all Danny.
You might think I don't have valuable things to say, but
Come on.
I do.
Even the guy don't know.
Didn't quite leave room for my other parenthesis here. So now it's just a calculator problem. Be careful with the parentheses and square roots and all that mumbo jumbo.
I like how your commas just kind of chilling next to that. You're watching that bridge thing where he hangs his leg. He's like running towards his family with his tongue out like a dog. I just remember him running like a dog with his head out the window with his tongue just hanging out, like running towards his house. Yeah. And then he jumps out.
Got it.
Didn't it?
Wait, that was the one where, is that the one that he thought he was glad?
Okay, what are you coming up with down here?
Yes.
Good one.
176
Yep.
I'm working there short.
and 2.071.
071. Yeah.
Okay.
You're one of those.
Like that question is it as they answer?
No, 2.0.
You are real.
There you go.
You're one of those.
I don't want it.
Oh.